All right. Hi, guys. The purpose of this lesson is to talk you through how you might do some of your problems on your Navigator session 7. So make sure you're checking this as you're going so that you know whether or not you're getting them right. Your learning goal for today is you'll be successful when you can use equivalent fractions and models to solve addition and subtraction fraction problems. Make sure you do your Gratitude Friday. What are you grateful for today? And then your warm up. I'm trying to find a fraction that is equivalent to 2/6. So the multiplication chart is really helpful for you in here. When you are working on a multiplication chart, if I'm trying to find something that's equivalent to 2/6, I could look for where I see them in the same column up and down. So for example, I see them here in the 2's. 2 and 6 are together in the 2's and also in the 1's. If I go off of the biggest number in the 2's, then I could make an equivalent fraction by dividing them both by that number. I could divide them both by 2. And if I do it to the top, I do it to the bottom. So if I divide by 2 and divide by 2, then 2 divided by 2 would be 1, and 6 divided by 2 would be 3. That would be one option for an equivalent fraction. You'll notice, though, here within your multiplication chart, 1 and 3 are right next to where I had 2 and 6. And the same would be true if I started to move the opposite direction. So instead of division, what if I tried multiplication? Because I can use multiplication or division in order to build equivalent fractions. So let's say I want to multiply. Doesn't matter what I multiply by. Let's say I'm going to multiply them each by 3. What I do to the bottom, and I'm going to do to the top, and vice versa. What I do to the top, I'm going to do to the bottom. 2 times 3 would become 6, and 6 times 3 would become 18. So if I look at my original fraction, 2 and 6 were right here. 6 and 18 should be in those same rows together as well. So here I see my 6 and my 18. They're making the same column or the same row as I look across as the 2 and the 6 were. Any of those front numbers, 5/15 could have worked, 8/24 could have worked, 9/27 could have worked. That's how multiplication charts are super helpful when you're trying to deal with equivalent fractions. All right, so let's use that to try and help us through our next one. So this time I'm looking at 1/6, and I'm trying to come up with anything that might be equivalent to it. So I see 1 and 6 together right here in my multiplication chart. If I have 1/6, I don't think I could divide by anything that they have in common because they're only in the ones together. But I could multiply. Remember, I could multiply to get equivalent fractions also. You can choose literally any number you want to multiply by, so long as what you do to the top, you do to the bottom. Maybe I choose 5. 1 times 5 would be 5. 6 times 5 would be 30. If I look, 5 is happening with 30, and it's across from where I was with my original numbers. Okay? Use that to help you as you're working through these problems. So I want you to come up with something that is equivalent to 8/12. You could simplify, reduce it, divide, or you could multiply. So for example, if I deal with 8 and 12, let's see, I see 8 and 12 right here in the 4's together. That means I could divide them by 4. So let's try. Divide by 4. And if I have to do that to the top, I'm going to do it to the bottom. 4 would go into 8 twice and would go into 12 3 times. This fraction would be equivalent. I don't have to divide, though. I could have also multiplied. So if I choose multiplication, I could multiply by any number. Maybe I want to do by 2. So if I multiply it by 2 on the top, I'm going to also multiply by 2 on the bottom. 8 times 2 is 16, and 12 times 2 is 24. This is another equivalent fraction. You just have to come up with one. All right, the next one is 8/20. 8 and 20. 8 and 20 are both divisible by 4, so you could divide by 4. on top and bottom to get your new fraction that's equivalent to it. Or remember, you could also multiply on top and bottom so long as the thing you're multiplying by is the same number. There are an infinite number of possibilities for these equivalent fraction problems. 3/6. So 3 and 6 have a 3 in common. I could divide them both by 3's. Or I could multiply them so long as I'm multiplying by the same thing on both the top and the bottom to build my new equivalent fraction. All right, so your work for today is you're going to see the next few slides. You're going to have some shaded parts. You're trying to figure out how much is shaded in each color and then how much you would have all together as if you were adding them together. So I see in my green that I have 1, 2, 3 pieces, and the size of the pieces are, let's see, there's 6 in the whole thing, so 3, 6. My purple, there are 2 shaded pieces, so that's 2 out of the 6. Altogether, 3/6 plus 2/6 would make 5. 5/6 that are shaded in. You're going to go through and do that same process, looking at how much is shaded in the first color, how much is shaded in the second color, and then adding them together in order to think about your total part that you have shaded. All right, so let's look at the pinkish color. I see 3, but out of how many? Well, instead of counting every single one, I could use multiplication. I see that there's 3 down and 4 across. So 3 times 4 is 12. So I have 3 12ths in the pink color. And the grayish blue color, 1, 2, 3, 4, 5, 6, 7, 8. 8 12ths. I'm adding them together to figure out how much total. 8 plus 3 would be 11. 11 12ths total shaded in. Okay, my green. I have 1, 2, 3, 4, 5 green. The size of these pieces are, let's see, there's 4 going down and there's 5 on the top. So these are 20ths. 5 times 4 is 20. So 5 20ths in green. In gray, 1, 2, 3, 4, 5, 6, 7, 8. 8 of the 20ths. I'm going to add my shaded parts together. 8 plus 5 more would make 13. They are still 20ths. They didn't become smaller or bigger. They're still 20ths. 13 20ths. All right, this color's a little bit hard to see, but I'm going to do the purple and then there's a yellow. 1, 2, 3, 4, 5. 5 purple out of, let's see, there's 5 on the bottom, on the side, and 6 on the top. So 5 times 6 would make 30. 5 30ths in purple. In yellow, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 30ths in yellow. I'm going to take those shaded parts, I'm going to add them together to see how much I have all together total. 12 and 5 would make 17. So these are 17 30ths all together shaded in. So you can use that idea of equivalent fractions to help you figure out the missing question marks on these problems. 2/9. I've built an equivalent fraction and I'm getting it down to 18ths. So I can see that 9 can turn into 18 with multiplication, multiplying by 2. What I do to the bottom, I'm going to do to the top. And 2 times 2 would make a 4. So this is now 4 18ths on this side. On this side, I can see 6 can also make 18, but it's by 3. 6 times 3 makes 18. So if I do times 3 on the bottom, I'm going to do times 3 on the top. And 1 times 3 is 3. So this side is 3/18. So now I have 4/18 and 3/18. I can use that to solve this problem. If 2/9 is really 4/18, and I'm subtracting 1/6, which is really 3/18. Now, since they're the same size pieces, they're all 18ths, I can just look at the numerators. 4/18 minus 3/18 would be 1/18. The 18th stays 18ths. This is the idea of common denominators, which is where we're going soon. All right, so your very last reflection problem is, do you understand adding and subtracting fractions best when you're using equations like what we just did, or when you're using the pictures, the diagrams? So which one works best for you and why? Okay, I hope this was helpful for you. Make sure that you have checked your work, you're editing your slides to make sure that you are getting as many points as possible on this Navigator session. And then don't forget to turn it into Google Classroom.